I'm Stephen Foskett, and this is Cloud Field Day coming to you from beautiful Sunnyvale, California. We are here at the offices of Druva, and we've invited in a panel of independent writers, bloggers, speakers, podcasters to interact and discuss during a presentation of Druva's technology. If you'd like to learn more about this, you can go to techfieldday.com and learn how to become a presenter or a delegate yourself. You can find more videos like this at youtube.com/techfieldday.
My name is Dave Packer. I'm the Vice President of Corporate and Product Marketing. Don't let that title fool you too much. I actually have a pretty deep technical background. So I'm going to be covering a little bit about company overview, but I'm also going to talk a little bit about kind of some of our core technology elements as well. With me today is also Bhaskar Sarohi, who's our Director of Field Engineering, Shay Verma, who is our Product Marketing Manager for InSync, and Ramanan. Completely blanked.
Director of Product.
Yeah. Sorry about that. Who's our Director of Product Management for Phoenix. It happens sometimes, I guess, right? So what I'm going to do is walk through a little bit about Druva, who we are. It's been, as was mentioned, it's been 5 years since we've done a Tech Field Day event. So good to kind of catch you up, find out kind of what's changed and how we're different. A little background on the company. We were founded in 2008. Our founders, Jaspreet Singh and Milind Bore, were basically the core founders of the company. They came from Veritas. And really, you know, if you think about Veritas, a very kind of classic backup and recovery model, you know, looking at, you know, the classic design of tar archives, right, and differentials and incrementals and everything else, which has really been the mainstay of the business for a long period of time. When they came and they founded Druva, their concept was, how do we break out of that particular model and make the data a little bit more accessible, a little bit more workable, maybe malleable is a good word, so that we could do other things with it outside of just kind of that core back and recovery design, right? And also kind of additionally add speed to it. And originally, it's actually a funny story. The company, when it was originally founded, was focused on server backup, data center, SQL servers, et cetera. And in a conversation with one of the early adopter customers, he said, you know, I really have a problem with my laptops. And suddenly the light bulb went on, and Jaspreet and Milind said, you know what, maybe we should be focusing in on endpoints, right? And how do we help actually people with laptops and mobile devices and et cetera? And that's actually kind of where the company turned and actually started focusing a large percentage of their business. From there, you know, 2008 was a great time to actually start a company. Why? Because it was also the initial phase of cloud, right? And when you really think about it, you know, obviously we all remember servers under people's desktops, we used to call ASPs, but at that particular junction in time, cloud was starting to gather steam. And as a company, if you think about it, if you were founded before 2008, you probably are pretty entrenched in your classic architecture, right? Your on-premise model. We had the advantage of creating an architecture that was originally designed on-premise, but also at the same time saying, wow, you know, there's this new technology stack coming up. How do we take advantage of it? And Milind, as our CTO, has always been a very thought-forward person to kind of leverage that technology stack. So in 2012, we announced our initial product, which is InSync, which has been our flagship product, which has really been focused on endpoints and cloud application backup. And Shay will go through that and kind of give you the demo of how that works in a little bit. I'm realizing my head's in the way here. So one of the key kind of tenets of, you know, as I talked about a minute ago, is really collecting data from all these different devices. And so we cover, you know, virtual machines. We cover, it's VMware, right, ESXi. We have a proxy that sits in the hypervisor environment. We have agents that sit on endpoints. And if it's a cloud application, whether that be, you know, Box, Google Docs, or Office 365, it's a direct connect from the console into the cloud application using their APIs. We then move that all over into, we collect that, and I'll talk about how we do that in a minute, but into AWS is our core infrastructure. We also support Azure. And you know what we do is we leverage the cloud native technologies inside that environment. So we're not taking a on-premise system and retrofitting it for the cloud. We're really, you know, we're using DynamoDB, EC2, and the additional services, and I'll talk a little bit about that in a minute within the cloud. And then on top of that is we then provide the various workloads, right? So Today, it's a mixture of backup recovery, test and dev, workload mobility for VMs, analytics. We do a lot of focus on data governance because that's a key pain point for all the kind of dispersed data that's out there today. How do you manage it for legal purposes? How do you manage it for compliance purposes, right? Identify data that's in there. And the reason we can do that is really because of the way we architected our system at the end of the day. So, how is that? So, building on top of AWS and Azure, we use obviously EC2. We use S3, S3IA, and Glacier. We do auto tiering inside of that, and on Microsoft Azure, we use Blob Store, their compute, and what we call Polaris DB, which is a NoSQL database that we organically grew inside the company to work in environments where there wasn't a highly distributed NoSQL database infrastructure. On top of that, then the kind of the core elements of our architecture focus around global deduplication, which is providing a client-side dedupe model, but it globally dedupes across all the devices. And so it's not unique to a single appliance sitting on somebody's infrastructure or a single site, right? Or a single user in some cases or server. The other part of this is we separated the metadata from the data itself. So, we're not storing, again, that kind of archive blob and doing incrementals. We actually store the data, and I'll talk about this in a minute, data separate from the metadata. And the metadata part is stored in DynamoDB and allows us to extend that metadata and use it for different purposes, right? So it provides a lot of functionality, allows us to do metadata searching, do deep searching, be able to do all sorts of things that you couldn't do if the two things were combined. I'd have to unpack, scan, search, do all those things. But I don't have to do that in this model. So that's that. We do, obviously, we leverage Amazon for replication, durability, et cetera, but we also do our own self-healing. We do integrity checks of the data, any blocks, and I'll talk about this in a second, any blocks that don't match that integrity check, we'll reclaim that block, recollect it as needed. But the real advantage of this system, the way we've designed it, is it actually provides a near kind of real-time in and out, right? The real bottleneck is your network at the end of the day, not the service itself. Because we have the elasticity and the scale that we're leveraging out of AWS, we can very quickly reassemble files, store them in there. We have people who've pushed within a 15-day, 20-day window more than 1.5 petabytes of data across their whole network at us. So it really provides a lot of high value and throughput and pulling the data out as well. So let's talk about the metadata and data separation piece for a second, because this is actually kind of core to understanding kind of how we do it. So the DynamoDB basically think of it as it's basically storing and journaling where all these data blocks are that are coming from all this data sources out there. So, if I've got a file, we're going to split that up into blocks, and I'll talk about it in a second. And I'm going to use the metadata journaling to basically keep track of all those block references. So what we do is we hash everything. So we hash the file, we hash at the block level, and we use that as part of the core data deduplication capability. And so within the metadata server, it's really all the references, right, all the URIs that are coming from S3. And then we basically, every refresh we do, which is basically what most people classically call a backup, we go through and we just make those block changes and updates within the metadata server, right? So at the end of the day, what it allows us to do is get a real high dedupe level. And then within object storage, what we're storing is the individual blocks that we're collecting, right, as individual objects. And those blocks are variable length. It's based on doc types, file types that we're collecting. Obviously, something that has a high dedupe has smaller blocks. Something that has a very low dedupe has larger blocks. But the important aspect of us, because part of our model is also providing a high level of security of all this, is the S3 storage in blocks. Each one of those blocks is encrypted and then stored with AES 256. That allows for a real high level of data obfuscation, right? Because if somebody were to get somewhere, I don't know how, but if they were able to get in there somehow, there wouldn't be any way for them to reassemble anything, right? It would just be a bunch of junk at the end of the day. because without the SQL, without the DynamoDB metadata server, without the ability to have all those URIs reassembled, it's basically nothing out there. Yeah.
What is that? The database, is that per tenant or per customer, or is that something global?
It's global, and it's separated by the fact that so S3 is in buckets, but at in the DynamoDB level, basically because of the way we handle encryption and logical separation, it's all within the same distributed database architecture.
Are there some kind of keys for the encryption, and who handles that?
So that's a great question. So what we use is we use envelope encryption, which is a standard out there. You can Google it. It's on, I believe, EMC's site as part of RSA. Envelope encryption, really who holds the controlling bits is the customer. Basically what we do is we generate a key for the customer when they initially instantiate the system. That key is then encrypted using a temporary password that's sent to the lead cloud administrator. They change their password, it changes the encryption of that key. We never store the key, actually. We only store a token. And anytime that token's challenged by an administrator or a user that logs in, they're using their credentials and their password to challenge that token, to unencrypt it. If it unencrypts, it just stays resident in volatile memory inside of AWS. As soon as they're done and that session ends, that key's basically destroyed. So it's never persistent anywhere, it's never stored anywhere. It's only within volatile memory the key would ever exist. So when you think about key rotation and things like that, your credentials and your password are really a proxy to that. And so by changing that, you're basically rotating the key because the key is in a position where it's very nearly impossible to compromise it. Okay. So the key never moves anywhere either. It just database, challenge, volatile memory, destroyed.
Okay, but there's only one required per customer per.
Yeah, because each individual. So the admin has the master, right, the cloud, and then he creates users. He's creating passwords for each of those users, and that password is really acting as the primary kind of key in a way. And if you think about it like that. But if you read about the spec on it, it's basically a way to protect the key and make it, and because it's in the cloud, it actually provides an advantage, right, versus being on premise, which would create a kind of a disadvantage. Because I have no idea what memory it's located in. I have nobody can access the systems, all those other things. So, any other questions on this piece? No. Okay. So, from an architectural overview, kind of going to your when devices or servers access the system, they go through what we call our cloud master. The cloud master has a config database to identify, your email address, and then it will redirect you to the storage node or the storage region location of AWS or Azure. Right. So one of the advantages of this model is actually customers can take advantage of any of the 31 joint regions between Azure and AWS. So we don't have customers that are just AWS or just Azure. It's basically one global view of all those storage locations. And each one of these then has stateless nodes that spin up based on workload demand, elasticity, and then those nodes then manage the data going into Dynamo and S3.
Do customers get to choose where their data lands?
They do, yes.
Okay.
Matter of fact, we have no control over that. You would come to us and you would say, look, I need to store my data in Germany. Okay. So we'll spin up your bucket in Germany. And then you map your customers or your end users, your devices and servers to that region. And it stays within that region. Yeah.
If I have an object store on-prem, do you work with that? Is it purely?
No.
No? Okay.
We can, as I mentioned earlier, we still actually have in-sync on-prem version of it. But what's happened in the last 3 years, and this is you all are very familiar with this, I'd say 2.5, 3 years ago, we were probably 90% on-premise purchases, and now it's like 2-3% a year. That's kind of how drastically it's changed for our business. That on-premise version does support OpenStack It is OpenStack Swift. Yeah, I heard it's Swift. So you know what? I got confused with the Apple Swift for a second there.
So with the config master that's using RDS, do you have that running across multiple regions, or?
No, it's just one central EC2 East, if I remember correctly. Yeah. And so, but that just basically acts as a redirector, right? Just to push people to the various regions. From a source-side global deduplication standpoint, as I mentioned, we use a variable block length algorithm based on file types. As I mentioned, depending on its images, docs, PowerPoints, SQL data, whatever that is, we do a lot of testing to understand what's the best dedupe block length for each of those file types. We create a local cache of hashes. So think of it kind of like just like a standard cache, right? So you get a cache hit or miss. You go to the metadata server. If it's a miss, check, see if that's a duplicate block or not. What the goal here is, though, is that within S3 storage, there's no duplicate blocks. They're all single unique blocks. So it's single instance storage. So that hash check that happens, basically, the client talks to the metadata server, and the metadata server checks the hashes and says, okay, this already exists. I'm just going to journal it. This doesn't exist. It's a miss.
You doing checking for a hash collision?
We actually concatenate a couple different hash algorithms together, so that you get one very long hash string to minimize collisions. We've actually never had a collision, and we have some customers who have over 2 petabytes a day.
How do you know?
We haven't seen it in the integrity checks.
Okay.
Yeah. So
the deduplication, is it a bucket boundary, or is it across multiple buckets, or?
Is it all your customers? Is it truly global or global for me?
No, it's global per customer. Sorry, I'm trying to make sure I understand it. So, because each customer has their own encryption key, right, and everything else.
Yeah.
And so and that's how we logically separate customers. And so you do the math, chaos, right? So the key is basically the primary controller. And so that's when we do dedupe, we store, but it's only within that unique customer.
As a customer, can I be on both AWS and Azure? And can I use the same key across both?
No, each storage region generates its own key, actually. Yeah, that's a nuance. So each storage region creates its own key. That way keys don't have to move. And then the RDS server keeps track of what's where, and who maps to what.
Okay. Is that within the provider, within the platform? If I'm across different regions, is that a different key? So if I have something.
Yes, if you're in AWS and you're in East and West, those are different keys. Yeah.
Okay.
And the metadata for those regions located within those regions? Or
Yes, it is.
location?
Yeah, so the deduplication happens across the metadata reach, right? And so it's within our region. Most customers we have in the US stick with one region, and so it's global. It's across the US. If you wanted to go farther than that, you can. What usually starts happening is you run into latency, or you run into regional data privacy laws that require you to segregate the data anyways. So.
How do you determine what you're going to cache locally?
You mean for the hashes?
Yeah.
So the cache hashing is basically on the most commonly used blocks that we see. So we'll cache those.
Most common globally.
Yeah, exactly, right. And how big is the cache size? Do you know?
Hardly any size, like less than 100 megs.
Yeah.
Do you support? Do you support in cloud going to? I'm going to use the Azure term. I forget the AWS term, but in Azure it's globally redundant, where you have your blob storage is replicated across multiple sites.
Oh yeah. So AWS supports redundancy across within a region. There's across a zone. There's usually multiple data centers, 2 or 3,
right,
and a replicate between the two.
Right. No, but across regions.
We don't support that today. Yeah. So we don't region to region replication. We don't support.
You mentioned AES encryption. You support FIPS 4?
We do. Yeah, 140-2 we support within GovCloud. We don't support that in the general public cloud, but we do within GovCloud. We have our FIPS attestation. We're about 80% of the way through FedRAMP actually right now.
I don't know if you're going to get into it, but it looks like the metadata in DynamoDB is pretty important, and I don't understand DynamoDB, so how are you protecting that?
Through encryption, and also since it's NoSQL, we basically are passing it a key and getting a blob back, right?
No, I'm sorry. So from an availability perspective,
Availability.
how are you protecting it, that you don't lose the data, you don't lose that metadata?
Of things what we do is, number one, the DynamoDB also has multiple copies, 2 additional copies of it. And also from a perspective, from our service perspective, if something goes wrong, we do not do immediate deletes into our database. So any changes in the database, like deletes, do not happen immediately. We also maintain multiple versions of it internally. So if we have to revert back from, let's say, if the consistency check is going on for data and we find something which has gone bad, we will go and revert to that.
Okay.
Is DynamoDB ACID? I mean, is it ACID related? I mean, is it consistent and all that stuff, or is it eventually consistent?
So you have to look DynamoDB from a NoSQL perspective. So
It's a NoSQL.
Yeah, right.
So it's a key value pair.
So it's not ACID then.
No.
So what happens if it does get damaged? And has that ever happened?
We haven't had it happen, no. And as he was mentioning, we have replication version back, so we can, if we have to go back, we can.
Okay.
Any other questions on this piece? So one of the things is okay, so I've kind of covered the basis is how we dedupe and how we're storing data. What ultimately we do is we create kind of a real-time file system, or near real-time, right, where we can store and retrieve instantly. There's no kind of reconstitution like you would think in a classic model, right, where you're full and synthetics and everything else, and your incrementals have to be I got to pick a date, now I got to wait for it to reassemble correctly, right? Within our system, and these guys can show it as well, you go back a year, pick a date, the files are instantly available to you, whether that's on a VM or whether it's a physical server or device, etc. So it's really nice from that standpoint, from speed and agility. Plus, it also, the other workloads we were talking about, like compliance and analytics and things, search and capabilities we're building into the product, or extending into the product, is that also provides then the ability to access those files and information in real time, right? So results can be drilled down to, et cetera. But the model we follow is really, you have your original full, and then you have your incrementals, right? And because we're globally deduping, we get a much smaller footprint. Matter of fact, on files, we've seen ratios on some systems up to 17 to 1.
Is that file system data?
Yeah, file systems, right? Whereas like a VMs will get like a 75% reduction or a 4 to 1, right? The other thing that we're doing in the background, as I mentioned, is we're also doing the auto tiering, which is moving it from S3 or S3IA based on usage into Glacier cold storage, right? Now, the advantage of this is that, and the reason we show it this way here on this diagram for visually represented, is we don't have to replicate the data, right? We're moving the blocks, but we're keeping the metadata server intact to keep track of them all, right? And so I'm not having this like mass, like, okay, I've got now, this 20 terabytes, and now I'm going to move 20 terabytes, and now I've got 40, right? So it just moves and sloughs off, and then over time, obviously, whatever your retention schedule is, pitches those data or those unique blocks that aren't part of something else. So I can just take 2 more minutes here and cover just a few other things, unless you have more questions. There is an option to have a software appliance that's an on-premise cache. So if you do have tight RTO and RPO times, we do support that. But the one thing interesting about it, it's not like a target appliance, right? So it actually stores only deduplicated data. The client still talks to the metadata server, and then it just stores those blocks that are deduped onto the cache, right? So you get a much smaller footprint on your cache, but you also have you can do immediate recovery from it, right? So it creates a huge advantage there. And what you can also use it for, we have a lot of customers that have, are in robo environments. They have maybe 200 sites. We have a logistics customer that has that. they also have a lot of low bandwidth sites, right? And so they want to be able to provide the service. What this allows you to do is basically cache local and then set a schedule of when it syncs the actual blocks up to the cloud. So if I want to do that, at midnight to 7 a.m., I can do that, right? But it's already deduped, so there's no overhead. And so you get a big reduction in the bandwidth support. And then I think this might be my last slide. This kind of puts it all together in a way, just another way to represent it. So, your server can go hot to the cache, right, and have more immediate RTO off the cache. That can sit. We have ways to schedule it so it can sit there for 30 days. Then it moves strictly to just warm storage. But keep in mind the cache will push data to warm storage, whatever that schedule is, right? So we have that advantage, and then moving that to cloud into Glacier in the long term, right? So we track that all for you. We manage the auto tiering, and ultimately, at the end of the day, is to make sure that it's cost efficient, right? So you're always in the most cost efficient storage for your data, depending on how it's being used, right? But at the same time, you always have a single view of all those snapshots, all that data, wherever it is archived in cold storage, warm storage, et cetera. So,
a couple questions.
Yeah.
So one on how is this packaged? So am I paying AWS or Azure one bill and you another bill?
No, you're paying us only, right?
Okay.
Through InSync, it's basically a per user pricing model, and that's what you pay us. We take care of all the back-end AWS. It's within our VPC. For Phoenix, it's a consumption-based model. So it's the post-dedupe compressed storage that you pay for. But that, again, you're paying us for that, and we're managing that for you.
So I assume the price changes if I do restores, right? Because
Nope.
I'm going to get.
We don't charge you for restores.
Okay. So if I bring back 5 terabytes of data.
It's fine.
Okay.
Yeah.
I'd love to know how the cost model on that.
Yeah.
We get on the front end to cover that.
We get a
back.
lot. I can't underemphasize how much cost advantage from the storage side we get from the dedupe piece.
Okay.
It's huge. If I look across, our whole set of data in the nearly 30 petabytes, I think the footprint is like nine of actually dedupe storage at the end of the day.
So when customers sign up and pay, do they pay for the full data set or the deduplicated data set?
For InSync, you're just paying a per user fee. You can as many devices as you want. For Phoenix, you're paying for the post dedupe. So it's deduped. Yeah.
Do you have any cool, unique use cases that you could describe?
I'll leave it up to these guys who are going to talk about the individual products. I think they have that in their own thing. We have some interesting use cases around compliance monitoring against legal hold, long-term archiving and retention. There's some interesting things we do because we have one thing I know Shay will talk a little bit, because it acts as a file system, we can support like a web dev connectivity to it. So you can, for example, we support that through legal hold. So you place somebody on legal hold, you can basically just go in through a web dev connection, mount all that legal hold data, work with it, or do a direct connect with an e-discovery solution and pull that data in directly without having to export it or put it on your SAN. So manage it. So it's a lot easier to manage it that way. But Shay will cover that in a minute. So, just one more slide. Sorry, I forgot that. So I'm running over a few minutes here. So this is in here, but it's really just kind of to give you a sense of the last few years. So 2014 is when we introduced Phoenix. That's what Ramanand's going to talk about. That was the year we introduced the e-discovery capability I just mentioned, the web dev connectivity, et cetera. And the cloud cache capability. In 2015, which was last year, is when we started supporting cloud applications, so Office 365, Exchange Online. We've extended that into Box and a few other things that we'll cover and talk about. One thing, example of extending the metadata set is we do forensic collection of data, of the files. So we actually extended it to support the greater amount of metadata required actually for legal process and legal admissibility. So that was something we added on, including chain of custody reporting into the system. So things like that, which are it was one of the interesting use cases we actually get hit with a lot these days, especially in big enterprises who are having, they might have, we have customers that have 5,000 employees on legal hold, for example, right? So it's not uncommon. And then 2016, we added in, like I mentioned, the Google Apps Cloud Backup, cloud-based DR, which Ram and I will talk to, test and dev capability, and then legal hold APIs, and some what we call pre-culling. If you're familiar with the legal hold process, you don't want to push all 90 terabytes of data. You really want to narrow it down to a date range and file type and a few other things. And we help companies do that so they don't have to pull so much data. It gets too expensive. Really. All right. And that's my part of the session.
Another question, like if you, let's say you've got a file and then somebody is trying to upload the same file so they get a cache hit, and then it's been deleted in the meantime while you have a cache hit here. Like, how do you guys make sure? Is it because you keep multiple copies of the data that you're able to not lose?
So we keep remember that we don't move files, we move blocks, right? So if if that block has a reference count to it, right? So if it's a count reference of 10, then that block will stay there no matter who deletes what files or whatever until that one file no longer.
Right. So I'm saying, let's say that data block is owned by somebody who deletes it, but you have that cache.
Oh, you mean on the local system? There's a cache hit or whatever.
Yeah.
You can talk to that one.
Yeah, definitely I can talk. So the way it works is the local cache is on the laptop, for an example, right? So it's going to only check on that laptop.
Right.
Whereas as a second user, when you open up your laptop, you want to back up that file, that local cache is yours. So the two caches are not talking to each other. Now, once the local cache check is done on yours, it will say, I don't have a copy of this. Let's take this hash, go to the cloud, and check in the metadata store. Now, the metadata store, if the deletion has already taken place, even from our store, then the block will again travel. But if there is still the reference, then it will say that, okay, just send and increase the counter. You don't have to send anything at all. One thing to add over here, the deletes are not like immediately, like the moment you delete it from here, it's going to be deleted from there, right? There's a job which we run in background which goes and deletes. So you have up to 24 hours before it takes place and it cleans up and all that. Yeah.
Okay. And so if you do backups, Phoenix, you back up VMs, right? Mm-hmm. Using a proxy, can I restore one file? Can I search for the files?
Yes.
So you can crack those VMs open, grab it.
Yep.
What about application backups? I saw you do SQL, right? Mm-hmm. Exchange coming or out? I saw
we
that.
Support Exchange online. We don't support. We don't. We don't. Right now, we're not focused on the core data center and high transaction systems.
Okay.
Right. We're focused on that next tier down applications, remote sites with Phoenix.
Okay.
Does Phoenix and InSync share the same metadata repository?
They don't today. The systems are, the architectures are the same. What's different is actually how they communicate with the cloud, because fewer servers, bigger data sets versus, we have customers that have 80,000 devices, right? So they're optimized differently. They could use the same metadata server, or just today we designed it for them to be separate.
How do you integrate with other products? So, for example, some companies might have high trust and they're using that to encrypt their VMs. Mm-hmm. So if I'm then backing that up with your product, you obviously can't go in natively and index that data or even to get it out. So do you integrate with any third-party products that do like file encryption or VM encryption or anything like that?
Not today, not that I'm aware of, no. Maybe you have a comment on that?
I can answer from a laptop perspective, right? And probably Ramnan can answer from a Phoenix perspective. Yeah. So on a laptop, let's say if you have a disk-based encryption which is enabled, right? So when our agent is running on your laptop, it runs as two processes are running. One is a syncer process, which is basically doing the hashing, sending the data to cloud and all that. The another process runs under the user context, right? So as a user, though it's a disk-based encryption, if I click on a file, that command goes to the file system and I can read the content of the file. Similarly for us, because we are running under the user context, we can read that file. Let's say it's a Word file or a PowerPoint presentation. We can read it. If the encryption blocks it, then we will just show that we couldn't read the file, and these are the files which we have missed in backup. So it depends how the content is coming to us.
Okay.
And it's a similar case for VMs as well, right? So I think this is something we're planning for the future as well, but where we would probably integrate with some of the.
Okay. All right, great.
So if you're not hitting the high transactions, it's going to end up with a tiered backup solution for a lot of customers. Right? You got your whatever you're using to hit the majors,
Right.
and then Phoenix to do the secondaries. Is that right?
Right.
How do you think customers respond to that? Most hate one backup solution,
Yeah.
right? Much less two.
Actually, we were just, Ram and I were talking about this earlier today. We actually have a lot of customers that have, maybe Commvault or Net Backup or whatever, and they're running us as well. Where we're coming in is really helping them manage all the remote offices and taking out the local infrastructure.
Yeah.
So that you don't have to have tiered storage and tape shipping, et cetera, at the local office or remote office or whatever.
But no consideration to do an on-premises solution of Phoenix to pull that back to a main data center?
Not at this point. I think what we are seeing, at least in the market, is customers are really warming up to the idea of getting rid of their secondary data infrastructure and moving to the cloud. So we're seeing that trend actually accelerate pretty significantly.
Yeah.
So we feel we're on the right path and kind of more.
I wouldn't argue with that too much.